Hello, welcome in this video lecture series for ACD once again. See, the last concept that we have discussed is about gain and bandwidth product, is it? And I told you that this is end of your chapter, and hence we need to start with some numericals. But to start with some numericals, let me summarize some formulas that we have seen throughout the whole chapter, is it? The formulas that we have derived for f beta, f alpha, or maybe ft, or the lower cutoff frequency, upper cutoff frequency, is it? All those formulas we will summarize here so that it will help us to solve some numericals, is it? So let us start with writing formulas. See, the first smallest formula that we have seen, and which one is completely new, is what GM, that is transconductance, is it? And I told you that it is IC divided by 26, that must be in milliamperes and that must be in millivolt. That's all. So that's why generally people write it is IC divided by 26. Right. Now at actual the equation is IC divided by VT. Right. The voltage at temperature, which is a standard one, a room temperature, what we call it as, is it? So collector current divided by the voltage at room temperature, is it? But what is the voltage at room temperature? And it is defined number, you have seen it, or no, you are in it from your physics thing, is it? It is this magical number, is it? So total temperature T, which we refer it as generally 300 Kelvin. If I want to express in terms of Celsius, then it is 27 degrees centigrade. Is it? That's what. So at room temperature, that is at 27 degree, Vt value becomes 26 millivolt. So that's why generally we use this IC in milliamperes divided by 26 as a formula for transconductance. Is it? So this is the first one. So whenever you want to calculate transconductance, use this IC divided by 26. Don't even move for this. What is VT? What is room temperature? At what room temperature I am calculating VT? Don't even think about that. Just go for 26 magical figure. That's what it is. Okay. Now the second formula is related to input, or what I can say, it is an internal impedance. So let me write it here. It is R B dash E. Look at this, virtual base to emitter, and the equation is HFE divided by GM. Right? Obviously, it's a resistance, means the unit must be ohm. Now, next formula is related to base spreading resistance, R B dash B. Is it? It is HIE. So we have not derived those equations. Those are some standard equations that we are going to use while solving our numericals. Right. So base spreading resistor is basically HI, that is input impedance of a transistor module. If I express the transistor in hybrid module, so HI minus R B dash E, base to emitter. So obviously it's a spreading of base, means base to emitter resistance has to come in picture. So this is RB dash B, that is base spreading resistor. Now it is all about resistor. See, we need to calculate only base spreading and base to emitter resistor. Rest of the resistors there is no need to calculate, is it? Now if I want to write this capacitor, that is junction capacitance. What is the junction capacitance? CB dash E. What we call it as CB dash E. CB dash E is sometimes referred as C. Look at this. See what happened to this pen. Wait. C B dash E we are talking about. That, just wait. There is a problem. Yes, that's what it is, CB dash E. Still not happening. Yes, done. CB dash E. So the CB dash E is referred as diffusion capacitance, that is CD, is it? And it has a value or equation is equals to Gm divided by 2 pi multiplied by this FT. And what is that FT? It is gain multiplied by bandwidth, gain bandwidth product, minus C B dash C, the another capacitance. Is it? Now what is that C B dash D? C, it is called transition capacitance. Is it? Actually those transition capacitance and diffusion capacitance, they have their typical values, as like HFE has typical value of 50, HI has typical value of 1.2 kilo. Like this, those CD and CT, look at this, let me write here CD, that is nothing but your CB dash E, has some typical value, and CT, which is nothing but CB dash C, has a typical value. So CB dash C has a typical value of 4 picofarad. Is it? Pico means 4 into 10 raised to minus 12 of farad. And what about CB dash E? That CB dash E has large value as compared to CB dash C. It is 27 picofarad. Pico means 27 multiplied by 10 raised to minus 12 farad. Actually, I must write a capital F because it's farad. Is it? Now, next formula is related to gain and bandwidth product. We know that gain bandwidth product means obviously a gain multiplied by bandwidth. Now, if I am referring to this gain AI, some people write it as an HFE, no problem at all, is it? And bandwidth means what? Bandwidth means approximately higher cutoff frequency. So, as we are in higher frequency analysis, I can write FH, or clearly I can define it by F beta. So, A multiplied by F beta. Is it? You know the formula of F beta, just multiply it with this HFE or AI, you will get gain bandwidth product. Is it? Or simply I can rearrange this equation as Ft divided by beta. Is it? That is Ft divided by Fe. Yes, it is just a different form, is it? So this Ft is equals to gain multiplied by bandwidth up to about 100 megahertz. Is it? So up to 100 megahertz, if you are working with an amplifier which has a bandwidth up to 100 megahertz, you can use this formula. Is it? So after 100 megahertz, there are some changes, some variations, or what I can say, some difference between the value of that F theta occurs. Is it? So that's why this is suitable up to 100 megahertz. Is it? The suitability decreases after this 100 megahertz. So we don't need to worry about this 100 megahertz because we are in a small signal amplifier. So how much frequency that we design is up to 20 kilohertz. Generally we design audio power amplifiers all the time, so we never went to 100 mega or such things as. Now the next formula, actually it's not needed to write formula for this F beta, but still as we derived, let me write that also in a summary. It is 1 divided by 2 pi R B dash E C B dash E multiplied by C B, sorry, plus it is C B dash C, and then after the value of capacitance I must write 1 plus Gm. The form is quite different. Now look at this. This is what something I am writing, a new form of F beta. Whatever you have derived is quite different from this F beta, but if you match them, if you compare this F beta equation with them, you will come to know that yes, I am writing the same thing. Right? So I think those 1 2 3 4 5 6 formulas are sufficient to solve some numericals. Is it? Now what kind of numericals actually we supposed to solve is a very small kind of numericals are there in this chapter. For example, let me write. For example, calculate the size of calculate size. Yes, it is okay. Size bypass capacitor. Calculate the size for FL, that is lower cutoff frequency uh, of 100 hertz. Look at this, for lower cutoff frequency of 100 hertz, when emitter resistor RE is 1K, HFE which is 50, HIE is about 1K. 1K means 1 kilo ohm, and one thing which is optional always, that is RS, is 600 ohm. Look at this. This is a very small question, very small numerical, and what they want from us, they want us to calculate this size of bypass capacitor. See, the size of capacitor means it's not a physical size, is it? Try to understand, it's not a physical size, it is a language which is written is quite different here. A size of capacitor means what they want a value of the capacitor, value in farad or microfarad, nanofarad, picofarad, whatever. The size means actually they want a value, specifically a value. Now see, everything is given, then I know this formula of lower cutoff frequency. What is the formula of lower cutoff frequency? It is or it has come under the title, what's the title we have written? Effect of bypass capacitor, is it? So it is related to bypass capacitor, so it will, you will find it under the title effect of bypass capacitor on frequency response. Then what's the equation we have derived? It is 1 plus HFE. If you have notebook, just check on what I am writing. It is 2 pi RS plus HIE multiplied by CE. That's what. Now see, is given, where HFE is, HFE is given. Yes, let me change the pen. HFE is given. Then lower cutoff frequency is also given. Where is lower cutoff frequency? Yes, this is lower cutoff frequency. Then RS and HI. Look at this. RS is given. HI is given. See, everything is given except. Then how you will calculate CE? CE will be 1 plus HFE. Look at those values already given. It is 2 pi. Just put RS plus HIE multiply by lower cutoff frequency, and that is done. Is it? So calculate the value of a bypass capacitor in farad or microfarad. See, equations are already there. You just need to put the values. Is it? Put the proper values which are given and use your calculator, not even brain. Is it? Just use the calculator and go ahead. Now, like this, we will solve some problems. Actually, let me check how much time we spent, because as I told you, it will be at the max 10 or 15 minutes a review of the things that we have covered. So 10 minutes are already lapsed with us. See, now henceforth one or two more problems are there. I can, it's related to sag, one is related to F beta. Missing things are well known. So instead what we will do, we will keep those problems for an assignment. Is it? We keep it for assignment. I don't know which assignment, whether it is assignment number 1, 2 or 3, whatever it is. There will be a numericals based on that chapter. I am going to give you a new assignment. That's what. Right? So instead of solving the same problems here and just using the formulas, putting the values and using calculator, you can do it by your own. Is it? Formulas are there with you, values are there with you, and even calculator is there. Go ahead and just calculate the values. So here the conclusion is, we are not going to solve any problem. I'm going to put it as an assignment of this chapter. Is it? So now officially we can say that we are done with our 5th chapter, and we can start with your next, that is 6th chapter, which is related to FET and MOSFET. Right? So that's what that is for the right now. Thanks a lot then.